It's recording. So we've all got a unique description. Okay. So we've all got a unique description. Okay. And we've all got a unique bit of code. Okay. I think it's called task 2 or something like that. Okay. So we've all got that information there. Let me just check this email quickly. Sorry. All right, so let's go have a look at this description. So a description looks like something like this. Now, what do we know about the description? What do we know about the description? Is this all correct or is this all wrong? Is this what we wanted to do or not?
What we want to do, yeah.
Yeah, this is what we wanted to do. Okay, so this is all correct, all right? This is exactly what we wanted to do. So we can work out what's expected based on this. So we're going to use this to develop some test cases. So you'll have a sheet that looks something like this. Let me get rid of these. Let me get rid of these. Okay, so you'll have a sheet that looks like this. Okay. And what we want to do is develop some user inputs. Okay. And then we want to work out what the expected values are. So having a look at this, okay, what we can see is that there's a bunch of conditions here. 1, 2, 3, 4, 5, and 6. This pretty much gives us our first 6 tests. Okay. So here, my limit is initialized to 38. So that's going to be this middle case. Okay. So that one's done. Okay. Less than limit, less than limit. I need to do the greater than limit and greater than limit. So I might do something like 50 and 80. I need to do something that's equal to limit and equal to limit. So I might do 38 and 38. I'll do something that's greater and one that's less than. So greater is going to be, I don't know, 105. And less than limit, I might do negative 20. If it was less, if input 1 is less than limit, so I might put 10 maybe, and input 2 is greater than. So I might put something like 39. Everyone's going to have different values because everyone's got a different assignment. And then the last one is the else case. So here, what do we got? So that could be something like equals and greater. Okay, so that's our else case. That gives us 2 more test cases. So I might choose something interesting, maybe negative 10 and negative 10, or 0 and 0, or maybe I'll choose some really large numbers. Okay. Have some interesting test cases as well. So you should have at least 6 that cover all of these, and then 2 interesting ones. If you want, and you want to make sure that your code works perfectly, what I'd recommend you do is you add some more test cases. You're allowed to add as many test cases as you like, within reason. So if you've got more than 100 test cases, put them into another file or something. But yeah, you can have up to 100 easily on this document, I don't mind. Okay. So we're going to focus on this one here. I'm not going to bother with the other ones because that's your job. So if I enter a 50, what do I expect the value of input 1 to be? 50.
50.
50, Okay, so that's fairly obvious. What about input 2? 80. Okay, now we get to the harder one. Expected value of temp. So input 1 is less than limit and input 2 is less than limit. And we get 7 plus input 1 plus input 2. So what's 7 plus 6 plus 5?
18.
18. Beautiful. Okay, so we get 18. Nice. And then the program creates an integer student number, initializes the student number. Program creates output, temp, which is 18. 18 plus the student number divided by temp. Now the student number here is this number. So we've got 18 plus 19886227 divided by 18, which gives us 1104,808.39. Now the decimal places don't really matter here. We're not formatting it. So you can put 2 decimal places, you can put 5, you can put whatever you like. That's fine. I would put at least 2 though. Okay. Then we'll do this one. So what have we got? We've got 9. So this is greater than and greater than. So we've got 9 plus input 1 plus input 2. So what's 9 plus input 1 plus input 2? Beautiful. So we've got 139. We're 139 here. I can't really see the. That's okay. And then we've got 139 plus our student number 19886227 divided by 139, which gives us 143,205. Oops. Oh no, that's right. 38. Does that all make sense so far? If it made sense, say yes in the chat.
Yes, it makes.
So what are we doing, like student number plus?
So if you have a look here,
139 plus student ID divided by 139.
the program creates an integer variable student number and initializes it to student number. Program creates a float variable output, temp plus student number divided by temp. So 139 plus the student number divided by 139.
Understood.
Awesome. And yeah, if you have questions, feel free to ask. I'm really glad that you're asking questions because better ask them now than later.
Yeah.
All right. So you keep doing that, okay? Don't worry about the actuals yet, okay? So you fill in all of that pinky color, I think it's orangey color. Then go and copy that. Put these all into all your test cases, okay? Oops, that one's from last session. Okay, so just put them all into your runs, okay? So you can fill in all your runs straight away, okay? Because the test cases and the expected is always going to be the same. Okay, if we go back to the ATM example, okay, I don't know where it went, but if we go back to the ATM example, after I've tested it, I want to make sure that these inputs still work, okay? So same thing here. Same thing here. I'm going to use the same test cases over and over again for each of my runs. And we'll talk about what a run is shortly. Okay, so obviously I haven't done all these, but you're going to fill those in with your values. And then what I'm going to do is go back to Photoshop. So how this works. Okay. So now we've got our test cases. Okay. So we've got 8 test cases. Okay. Now we're doing this manually. In the future, you'll do this automatically. And it'll be thousands of test cases, but right now we're just focusing on a small number. So what you're going to do is you're going to take your code and you're going to feed it into those 8 test cases. You're going to report, okay, what happened, okay, and is it all good? If it's not, we go back and do it again. Otherwise, we end. This doing it again is called a run. Does that make sense?
Yeah.
Awesome. Awesome, awesome, awesome. So now what I'm going to do is make sure that my code can actually show me these intermediate values. Okay. So what I'm going to do is I'm going to go to my code and I'm going to add some checks. I'm going to check input 1, I'm going to check input 2, and I'm going to check temp. Output's already printed, so I don't need to worry about that. Okay, so output's already printed. Temp isn't, and input 1 and input 2 isn't. So I'm just adding a check in there. I'm not editing the code, okay? I want to see how badly my technician did, okay? I want to see how bad the code is first before I go and fix it, okay? So don't fix it at this stage, leave it as it is, okay? You can add some checks, you can add to it, just don't edit it, if that makes sense. Okay, does that make sense? Awesome. Awesome, awesome, awesome. So now what I'm going to do is I'm going to find this code. Oh, damn it. All right. For some reason, this is disconnected. Second. What are we doing? Assignments. All right. So now what I'm going to do is I'm going to compile my code. My code is something like this. Okay, so I've got cc minus -4 minus -0 task, and then the name of the file. Okay, compiles fine. Some students will have warnings. You can just ignore the warnings until you go and start fixing it. Okay. So what we're going to do now is I'm going to run it. Okay, and I'm going to try. So I'm going to try some of these values. So I've got 5, 6, and now what we do is we come here, running out of room, and we enter what it gave us. So we got a 5 and a 6. Our temp value is 8, and our actual output is 2485786.0. Okay. Oh, that is not to be done. So that one came. So the 2 inputs came out correctly, but the temp and the output came out incorrectly. Now I'm not going to fix it yet. I'm going to go through all the test cases first. Okay. So I'll just keep going. So we've got 50. Okay, to confirm where the problem is and also to avoid false positives. Okay, so we've got 50, 80, 139, 143205. Okay. So if we have a look at that, we can see that these are coming out right now. Okay, but this is still wrong. Okay. So now what we can do is we can think about fixing it. So that'll bring us on to our next test case. So let's say I've done all 8 of them. I'll go ahead and try and fix it. So I notice that this is coming out wrong. And I know that this is part of this second if else. So I go back to my description, becomes 7 plus input 1 plus input 2. Well, I've got minus there, so I need to change it to a plus. So I'll save that. You can change as much as you like. Go rerun it. And I'm going to try 5, 6 again. This is my second run now. Okay. And what am I getting? I'm getting 5 correct. I'm getting 6 correct. I'm getting 18. But I'm getting this wrong. Okay, I'm still getting this wrong. Okay. So with that, I know that there's probably something wrong with my division down here. Okay? It's probably the fact that it's not floating point. I've got an integer divided by an integer, which you know how to fix from lab 1, I think. Yeah, lab 1. Okay, and then I just keep going until I've got all greens. Does that make sense?
Yeah.
So in terms of decimal places for the testing, it doesn't matter what you write there, as long as it's clear that you're correct or not. Your output is 4 decimal places. Be aware that there might be some floating point error. Okay, so if you have values that are really close, okay, so if you have a look at these 2 examples here, so I expect the answer to be this, but I keep getting this, chuck it into this formula, and if you get a value less than 0.00001, you can consider that a pass. Okay, so if it has a 0.00001% error, that's fine. Now, once you've done that, make sure you save it as a PDF, and that's that task done. Okay, it's not a very long task. That's basically it. Does that make sense, everyone? Did anyone not understand it? That's it. That's all it is. That's all it says to do.
Thanks so much.
That's all right. What didn't you understand, AJ? Okay, so if there's something that didn't make sense or if you want to confirm something, let me know. So just a couple of points while you're here. So as I said, you can add as many more test cases as you like. And if you need more than 6 runs, just copy and paste and just keep adding as many runs as you need. Okay, you will not be penalized for having more runs. So if you're getting the floating point numbers wrong, and you are getting floating point numbers, you're not getting 0.0 or something like that, check it against this formula here. Okay, so if the floating point numbers are coming out wrong, check it against this formula. Yes, so until you get all the values, that counts as 1 run. So I would do this 8 times. Okay, so I've only done it twice for the example, but I'd do this 8 times, and then I'd fix it, and then do it another 8 times. Okay, so if we go back to this here, every single time I do it 8 times. Okay, I should have said in here, fix. Okay.
Sir, like, can we run same values? Like if we are not getting a proper means wrong answer.
Yeah.
Like if we are giving 5, 6, if we are getting wrong, then
Yeah.
again we can give 5, 6 in cases, or we need to just give all different 6 cases and
No,
just
no,
run
all
once again.
exactly the same test cases. So if you have a look at the assignment, it says it on there. Exact same test cases. So it should be the same test cases every single time. For task 2, you don't need to write any comments.
So it should be like 2 PDF files, one for the test cases that are wrong and the other one that are being corrected, the logic, after correcting the logic. Is that?
We've got the original code already.
Yeah.
So we don't need that. What you need to submit is the assignment, task 1, fixed, the test cases, and then the code that's fixed. Okay, we've got the original code, so you don't have to worry about that. Okay, so there's 3 files that you need to upload.
Okay, sir.
So 1 is a PDF, 2 are C files. And they need to be C files, not text files, not docx's, C files. All right?
So how can we just submit if like we are downloading first, there are some errors in assignment 1, task 1.
Yep.
If we are fixing the code, then that fixed code should be like submitted once again for this task 2.
It's different code. They're not the same. Task 1 and task 2 are not the same code. They look similar, but they're not the same code.
Okay, sir.
They look very, very similar, but they're not the same. Okay, so if I take an example, what's your student number? Oh, let's just pick a student number at random. But if I take, oh, it's not, wrong thing, that's the lab. Where are they? Where's the assignments? Students. So if I take an example, you can see that's a task 1, that's task 2. They look the same, but they got completely different values. Okay, they're not the same problem. Okay. So they're different files. How to write test cases? We just went through that. What didn't you understand? You need to be more specific because we just went through it. Now this is the lab. So give the user's inputs, what you expect to happen based off the description. That's it.
Hi, man.
Oh, okay. Can I just answer this person's question? For task 3, is there an input? No. So for task 3, there is no input. It's your student number. I don't even know why you need the student number. What's the assignment? I'm trying to remember. I wrote so long ago. Assignment 3. Yeah, so this should be your student number that prints. You can just hard code that. That's fine. Yep. What was your question?
When I'm trying to find the floating number, it's just giving me the wrong number, like 0.0000. The actual value is 0.5000.
Okay. You have got a floating point division?
Yep.
Okay, then just chuck it in this formula. And if it comes out as less than 0, so can you put the values in the chat, the expected and the actual? And I'll show you how to calculate it.
My input one is
Just put it in the chat while I find. So. No, the actual value and the expected value of the.
oh yeah. I just kept that.
So we have to fix task 1 code, we have to fix task 2 case and test case.
Task.
Yep. So sorry, someone else is asking a question. They're asking it privately. It's a little bit annoying. These are the 3 files that you need to submit. Okay. .c, test cases, .c. Does that make sense? All right, so in terms of, oh yeah, that's a very large number, that's why. All right, so, no, task 1 and task 2, you do not need to write comments. You can have a look at the marking rubric. Okay, there is a marking rubric there. So if you go down, there's nothing about comments, okay, except for in task 3. Okay, there's 2 marks in task 3 for your description, but not for the other ones. All right, let's get, I'll get to your questions. Give me a second. Sorry. Yes, you need to accept the agreement. You need, so, give me a second. Sorry, let me just sort something out. Give me 2 seconds. Okay, so let me just answer this question first. So, where is this? So, if you're getting a floating point error and you're definite that you're using floating point division, get your calculator out. What have we got? We've got, which one's the actual? Oh, that one's the actual. So we've got 1.254 minus 194.5. All that divided by expected, times that all by 100, and you get 0.000005, which is less than 0.00001. Okay, so it's fine. It's considered a pass. All right, so just use that formula. Does that make sense? Satish?
Yep, all good. Can I keep it in the red color one?
No,
In
no.
the
So put it green. So it's
Yeah.
considered a pass.
Sure.
Okay.
Thank you.
That's all right. All right, so comments, that's done. All right, so someone asked about the agreement. So with the agreement, you need to read it and you need to make sure that you do agree with it. You just click on this, continue the preview, read every single one of these, okay? Make sure that they're true. If anything isn't true, you need to let us know immediately, okay? And then you need to say agree. This we then can use later on if we need, if we suspect your work, okay? All right, any other questions? So where do we get the actual value? We get the actual value from the code. Yes. Unaware of what? Yes, you need to complete the AIM module. So you should have it on your LMS. If you go to my LMS, it should be somewhere here. Obviously, I don't think I've got it as a staff member, but yeah, look, I might have it. It'll be the very last page if it is there. No, I don't have it, but it'll be some little AIM module there. So just have a look for it. It'll take 5 minutes to complete. More questions? Have a look now. Tell me if you can see it. Unfortunately, I can't see it, so I'm not sure.
Hey, how are you, Matt?
Hey, how are you?
So I'm just kind of confused with task 3.
Yep.
I'm kind of struggling with the 5 numbers in each line.
Okay, so the way you should think about something like this is comparing it to how you would do it as a human, okay? Which might sound a little weird, but it's one of the best ways to solve some problems, because what you've got to remember, if we can do it, then a computer can do it, and it can do it very fast. So if I had to print numbers, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, let's start with 2, okay? So if I had to count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. What's telling my brain to stop here? What's telling me to stop there? Why did I stop there? What have I done as a human? How am I able to know to go to the next line?
I don't know.
You don't know? Well, so basically in my head, I'm counting 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Maybe unconsciously, but it is happening, isn't it?
Yeah.
I can scan the line and I can count. So maybe what would be helpful is to have a second counter that's inside of your loop going up every single time. And then you can say, if it's 5, then we print a new line.
Yeah.
Yeah? I think I've given you the answer.
Yeah, okay.
Okay?
Yeah.
Cool.
Right, thank you.
That's all right. Okay, should we submit PDF or C files? One file should be a PDF. Let's go back to C. My favorite. There should be one C file, one PDF, one C file. So 2 C files, 1 PDF. Okay? It's also on the assignment sheet. Let's see assignment sheet. Did have it. Let it go. All right, so on the assignment sheet at the top, code submitted for task 1, 2, and 3, submitted as a .c file, and the test case is a PDF for task 2. Okay. We're trying to download the code using copy command and no match in Unix. I don't know what's wrong with that. Can you please help me out? Jushang, I think it is. What's your student number? Space ends. What do you mean space ends? I'm so confused. So, oops. Okay. All right. So copy tilde CSI lib. Hopefully it works. It's kind of really embarrassing. CSC1. Yes. Students. Assign 1. 201. 0. 71. Space dot. Oh, we have no match. When did you enroll in the subject? Oh, that's one. Oh no, I got it. It's there. Yeah, it does work. Sorry, I wrote a 9. Definitely works. Yes, every single student has their own code for both tasks, or for all 3 tasks. Yes, you need to read the assignment. If you submit someone else's code, you get 0. Okay, regardless if it's your own work or not, every single student has their own code. The agreement is just for submitting. So you can download the code beforehand. Okay, it tells you how to download it here. Okay, you can download it at any time. Okay, every single student has their own bit of code. Okay, and we know what they are. So if you try and submit someone else's, you just get 0. Okay, how to write test cases. What do you understand about what we went through before? So we write the user inputs based on the description. Okay, we've got a description there. We make sure that we cover all of the cases. Okay, so input being greater than limit, input 2 being greater than limit. That's that case. Input 1 being less than limit, input 2 being less than limit. That's that case. What do I expect input 1 to be? 5, because I entered 5. What do I expect input 1 to be? I expect it to be 50, because I entered 50. What do I expect input 2 to be? I expect it to be 6, because I entered 6. What do I expect input 2 to be? I expect it to be 80. Then I need to calculate the value of 10. 5 and 6. 5 and 6 are less than, so 7 plus input 1 plus input 2. 5 plus 6 plus 7 equals 18. Then the value of output is temp added to student number divided by 10, which gives me this big number. That's how you write the test cases. You just do it based on this. Actual value, you run the code, just compile and run the code. So you've downloaded your code, okay, based on the assignment. Remember, everyone has their own unique bit of code. Every single one is unique, okay? I think there's a one in, I think it's 10 billion chance that you get the same code as some other student. So you mean wrong code. You've got, if you download the code, you'll get a bunch of files. Okay, so you get these 4 files. Assignment 1, task1.c, assignment 1, task2.c, description, and task 3 description.
Okay, sir. Okay. So, like for task 3 code, we need to submit separate.
Yes.
Task 3.
If you want to submit it early, you can just submit it with the others. It's up to you.
Okay, sir. I'll just look up for that. If everything's right, I will just let you know. Sir.
The code that's not right is this code that you downloaded. And you're going to fix it as you go. All right, is there any other questions? All right. I really need to show this. Actually, I'm done with the chat.
Can you explain the task 1, assignment 1, task 3, sir, one more time?
Task 3?
Yeah,
Task
task
3. Okay, so task 3 is due a little bit later. Basically, task 3 is going to be very different for every single student, but it involves at least one for loop. So I'd recommend before starting it, go and watch the for loop video. Okay. And one if statement, which you already know, because you've done the labs, if statements. Okay. And then, I wonder if I got a sample. I don't think I made a sample. Oh, actually, I might have a sample. Let's see my samples. All right, so I'll just do, oh, there's a sample. Cool. So that's a sample, okay? First, to print the values to the screen, the program must print the values starting at 622 down to 6, not including 6, decrementing by 8. Okay, if you watch that for loop video, it'll tell you pretty much how to do that. Each line must print 6 numbers. Okay, so you can see here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is where your if statement comes in, because you can say if it's the 6th number, enter a new line. So print a new line. Each number must be formatted using a width of 7. Everyone's going to have a different width. The number must be left justified. Some people will be right justified. Some people will be left justified. There is no space needed to be added between numbers. Rather use the width to create the space. Okay, so don't add any extra space. Program must have a description at the top. Program must print your student number. Okay, so you just need to change this with your student number. This is what it should print out. Okay, everyone's is going to be different. So if I take someone else's, you can see this one's really long, different widths. This one's right justified. If I take this student's, it says it's very short. Okay, everyone's going to have different values. Everyone's going to have different bits of code. Okay. And just so you're aware, this was all written in C, the program that generates this all. Okay, so you can do some really cool stuff with C. So yeah, C is generating C. Did you download them? So if you can't see them, it may be just that you need to refresh. So press this little green refresh. Is there any other questions? So I think most people got their questions answered about.
Sir, shall I share my screen because I'm unable to download that files.
Okay, what's your student number? I've got your student number. All right.
20.
You're gonna copy me.
Friday तो close है और Easter है.
P.
Yes, sir.
Tilda. CSI live.
CSI live.
E1PES. Students.
आओ तुम खाना तो खाने हो मैंने खा.
Sign one. What was your student number? And then, is this your student number? I don't know. That's your student number.
No, sir. 20662453.
No.
2453.
Star space dot.
Oh, I forgot about the star.